application and helps you manage how petabytes of data in terms of storing and manipulating that data, playing with it, and it's basically inspired by the MapReduce concept introduced by Google and the Google file system distributed concept that was initially presented. Google presented certain papers on that. So it provides you fault tolerance kind of functionality, queryable data, distributed file system, open source formats, and other functionalities. Basic components that involve Hadoop project are like HDFS, which is Hadoop distributed file system. Then you have Hive, which is basically a queryable data warehousing interface. Then you have Pig Latin, this script talked about by Sanjay, and HBase, Zookeeper. So these are basically the sub projects of Hadoop. So I'll briefly talk about what actually HDFS is, because the understanding of HDFS is necessary to move ahead in terms of discussing this solution or the problem that I'm going to talk about. So HDFS is basically a distributed file system provided by Hadoop framework. So it basically consists of a named node which is responsible for maintaining the metadata in terms of where the files are stored, what all related to the metadata information for the file storage that you're actually performing on HDFS. So the named node is the primary responsible component for taking care of all these details. Then you have the data node, which actually stores the actual data in terms of the data is divided, the files are divided into sub parts, and this data nodes, these are the individual nodes or the machines where you actually store the data component of that HDFS files that you are storing. And these data nodes actually provide you the capability of data replication as well. It's like a block of data is not necessarily being stored on a single data node. It might be replicated various data nodes to provide you the failover functionality. Say one of the nodes goes down, so you have another node for your rescue from where you can actually pull out data and do your processing. So all these things are being maintained by the HDFS itself. So in this diagram we can see that we have a rack of data nodes. We have a single named node, and the clients actually communicate with the data node to pull in the data out of the HDFS. So next I am going to talk about a bit about the distributed MapReduce concept, which is basically the crux of the Hadoop framework. So basically it provides you a MapReduce kind of approach wherein you actually divide a particular task into subparts, and those subparts are independently executed on individual machines, right? And once those subparts are executed, you combine the results of those subparts and create the final output of your job. So as we talked about the HDFS machine nodes, generally the HDFS machine nodes where the data node is actually stored, they actually act as the executor for this map operation that we are talking about. And finally they emit out some results which are finally combined by the reducer tasks, and the final result is produced in form of a file on HDFS itself generally, or you can actually get it out of the HDFS as well. Okay, so the basic concept on which this MapReduce actually works is moving data to a place where the computation is present is always expensive in terms rather than it's easier to move the logic of computation to the data. So it actually revolves around that concept. So it actually acts as a it's very natural for doing log processing, ad hoc querying, and web search indexing, the click information that is generally stored over the file systems, which tends to be very huge. Okay, so moving to Hive, what actually Hive is. Now Hive is a data warehouse framework which allows you to perform ad hoc querying operations over the data that is stored on Hadoop file system or HDFS file system. it it basically provides your RDBMS like view over that data that is actually stored on the file system, and it has got an efficient SQL to MapReduce interpreter kind of thing, wherein you actually specify a SQL which is internally converted into a MapReduce job, executed, data is pulled out from the HDFS as desired and returned back to the user in form of a records, plain records that you actually see in RDBMS. So it also provides you the capability of running in a server mode, wherein you can actually communicate to the Hive server as you do it with any normal data source, RDBMS like data source like Oracle or SQL. Okay, so if we have a look at this diagram for HDFS and MapReduce, so basically the primary division is in terms of three verticals. The first vertical is the client components, which are used for interacting with the Hive system or the framework. So it includes your JDBC or DBC drivers that come with Hive, or you have a web UI or a client interface provided by the Hive framework itself. So then you have a HiveQL query language parser, planner and optimizer, which actually understands this query that you are actually writing, and after understanding it, it converts it into a MapReduce job using this execution part. So this execution part is actually a part of MapReduce vertical, wherein the MapReduce tasks are then submitted using various UDFs or user serializer, deserializers, and then data is fetched from the HDFS, which is actually stored in form of flat files, generally in terms like unstructured data, the log files, the CSVs. Okay, and for this complete information, it actually stores some metadata onto a separate RDBMS kind of helper data source, I should say. So generally by default it comes out to be a Derby database that is shipped with Hive, and you can actually configure it to some MySQL or Oracle kind of database where you want to store the metadata. Now what that actually metadata is, it's basically the mapping of the logical files that you have stored on the HDFS against the tables that you have created out of those files, right? So you have to actually create a schema out of the data you are actually storing when you are talking about Hive, right? So that metadata information is stored in that metadata database which is outside this Hive system, and it uses the Thrift API to communicate with that. Okay. I hope I'm making myself clear on this part of architecture of Hive and Hadoop like HDFS. Okay, so before we move ahead, let me talk about a problem like we have been discussing about this framework. Now whenever we talk about a framework or technology, it comes with its sets of like next level thought process that you need to tickle around with. Like what if I start using these kind of technologies, what else do I require to bring out a complete solution out of these things? Now it has been discussed in a lot of forums everywhere that moving forward we'll have a lot of structured as well as unstructured data lying around everywhere, right? So now there lies the a problem, or I should say an opportunity for us to provide a mechanism wherein we provide some kind of analytical skills over that structured and unstructured data that is available. So like, because the data is huge and it is unstructured, certainly it's not going to be easy to provide analytics over it, right, in terms of visuals. So so if we talk about a problem like we have Hadoop clusters, thousands of Hadoop clusters where the data is stored, right, and you have to bring out that data and convert it into useful information so that analysts and other people can actually use it for better businesses, right? So now how do we analyze and at the same time leverage the power of distributed computing provided by Hadoop for achieving what we want to do, right? So we actually did some R&D on that, and the general convention that is being followed at this point of time is somewhat like this, that you have a cluster containing the Hadoop files over a Hadoop cluster, like then you write some MapReduce jobs, either using custom codes that you write, or you use Hive interface, and then you migrate that data to a data warehouse, and then you actually do reporting and BI over that data, polished data that you are bringing in from Hadoop clusters, right? So I guess this is the general approach that is being followed everywhere at this point of time, right? Dealing with the huge data sets that are available at Hadoop clusters. Now, can there be any improvements in terms of, can we follow another strategy, or can we introduce some kind of mechanism by which we can actually overcome some of the shortcomings that we generally see with this kind of approach? Like the one that I see is, you have to produce redundant data in terms of, you already have data on Hadoop systems, you have to bring in some part of that data and put it into a warehouse, right? Because you're bringing in redundant data that automatically comes up with in terms of, like, you'll have to spend some time in doing that, so efficiency is also into picture, right? Then it becomes really difficult to maintain these kind of warehouses. Like, you have to clean them, you have to maintain or create snapshots out of these warehouses, because when you're talking about a warehouse database, it has got its own limitations, right? So at certain point of time, it's going to hit that bottleneck, wherein you'll have to move your data out of that warehouse to some tape or some other location and bring in new fresh data to analyze it. So can we have a mechanism wherein we do not have to truncate that data, or we don't have to deal with that kind of a situation where we have to hit that bottleneck of a normal RDBMS data source, right? So we thought about that, and we came up with a strategy wherein can it be possible to provide direct reporting over Hadoop data, right? Obviously, we are talking about some kind of interfacing with that Hadoop data sources that are there, right? And extracting data from there, instead of bringing in data in terms of a data warehouse where you need another reporting tool to communicate with that data source. Can it be possible directly use that data that is stored on a Hadoop file system, okay, and then provide reporting or dashboards or ad hoc querying over that data, right? So, and at the same time, can we leverage the computational powers of Hadoop? Like, can we have our own custom MapReduce jobs introduced in between, which are executed, transform the data on the Hadoop file system, and finally the output that is there, it can be used for dashboards, reporting, ad hoc querying. You can actually create visual charts out of it, that kind of thing. And overall, like, because the data we are talking about is kind of semi-structured or unstructured, right? So can we provide some kind of structuring mechanism over the Hadoop data itself? We do not have to bring in the data into a structural form in an RDBMS first, and then provide reporting over it. Can we do directly it on Hadoop? So that is the idea that we are talking about. The structure, we are talking about a virtual structuring of data rather than a physical structuring of data. Because we do not want to bring in that data first, like, because the data can be huge, right? So we don't want to bring it into our system first, hit that bottleneck of performance, and then provide a structure, right? Instead of just create a virtual layer over that data, talk to that data using that virtual layer, and extract meaningful information out of that data. So that is the idea that we are talking about, right? So now I'll briefly talk about a solution that what we are actually trying to design here is basically we'll create a structural meta layer, a virtual meta layer of objects over the data that is actually stored in Hadoop. Now what we are achieving through that is, obviously I've already discussed that the performance bottleneck is gone, because everything we are talking about is virtual in terms of the layer that we are going to communicate with, and it will provide you with ad hoc transformation capabilities. what I mean to say with ad hoc transformation capabilities is like the end user who's actually dealing with that data will have the capabilities of playing around with that data. Okay, I want to see the sales of a particular state. He can just select a criteria at the runtime while he is actually viewing a report or a dashboard, and in a flash the data will be job will be submitted to the Hadoop system, processed, and the data is being returned back. Now the obvious question that comes into mind at this point of time is the performance, right? So obviously doing it on in real time terms will definitely be done on a smaller data set, right? No one would like to analyze 1,000 million records instantly, right? Even human mind is incomprehensible for that kind of information, right? So if you have to do that, you have to summarize that data in some way or the other. So herein the transformations actually come into picture. You modify the data in such a way that it becomes comprehensible, right? Using these transformations, right? These transformations then can be executed asynchronously, right? You don't have to execute them in a synchronous manner. You can submit these jobs which are actually doing these operations asynchronously using a simple UI, right? You don't have to write a MapReduce implementation for doing all those things, right? You have a custom MapReduce implementation which you can actually plug in, but the front end that is being provided to you is very simple in terms of you just select those MapReduce transformations and execute them. So that is the idea that we are talking about, right? So once you actually perform these transformations, it allows you to visualize that unstructured data in form of a useful information, right? You bring in that data in form of dashboards, charts, crosstabs, matrix, grids, whatever you want, the possible options that any BI reporting solution provides, right? So now what this is the concept that we are calling as visual Hive. Like now I'll briefly talk about what all we actually did for achieving this kind of behavior and what we are doing to bring it to the next level, right? So the first and foremost thing was that was required for us to having the capability to talk to the Hadoop file system in such a way that the information is extracted from there in a meaningful way. So the obvious choice that came to our mind was Hive, right? Because Hive provides you with a mechanism of data warehousing interface, right? So you can actually write queries which are executed as MapReduce jobs, right? So we use Hive for doing that. We interface with Hive, we provide Hive as a standard data source as a part of our solution, right? You can connect to a Hive server running in server mode, okay? And you can communicate to that Hive server using JDBC, okay? So for supporting that, the driver that currently Hive provides is very trivial in terms of the implementation, right? So we had to enhance some connection and prepared statement classes for achieving what we actually wanted out of it, okay? We are trying to push these changes as part of the GA so that they are readily available everywhere, okay? Now, as I talked about Hive as we started supporting Hive as a standard data source. So obviously the data that is actually stored on a Hive system has to be presented to the end user in a easier manner to access it and design reports of like queries over it. So we have a query designer which will allow you to perform drag and drop operations. So you can see that here what we have is, this is the connection that I was talking about. You can create a connection out of the Hive server, okay? Then this is the query designer that I was talking about, wherein you can actually select the tables that are present on a Hive server, okay? You can just drag and drop these tables onto the query designer. You can write your queries, you can modify them manually. You can use the designer for doing that, and once you do that, you will be able to create a meta layer out of the system, which can next level usage will be like creating dashboards and reports and ad hoc querying over it. Okay, so once this configuration is done, then it provides you with a virtual data layer that you have already created. Now this data layer has the capability of providing you capabilities of transforming the data in whatever way you actually want. Say you want to filter out some data out of this object that you have created. Initially it was just representing a simple file that was coming out of the file system, right? The complete data from that. Now you want to filter it based on certain criteria. So what you can actually do is you can specify some transformations over that data in terms of filtering, sorting, other transformations like changing the groupings and converting it into a deflate kind of an operation where you actually turn the records in some form of rows, right, which are actually represented as columns. Okay, so these kind of transformation capabilities are available. Okay, so now these transformations are actually executed as Hive clauses, filtered clauses on Hive system itself. So what we are doing here is we are allowing you to add filters to the tables that are available. The Hive is converting them into the MapReduce jobs, and those MapReduce jobs are actually being executed on the Hive, on the Hadoop system, and bringing in the required data that you want to view, right? So that is where we talk about leveraging the capabilities of Hadoop file system for processing the data, right? Then this business modeling thing is like, it provides you a virtual view of data where you can actually represent your business entities in terms of these objects, and you can play around with these business objects. You can create reports, dashboards on these business entities that are being represented, right? And it provides you with the analytics over this meta layer objects that we are providing, wherein you can create reports, dashboards, chart splits, alerts, already discussed, ad hoc transformations. Okay. Right. So that is what we are actually providing at this point of time. Where do we see ourselves moving from here is like, we would like to provide a mechanism wherein we have this meta layer component which have the capabilities of taking in custom MapReduce jobs written by the end user. You have some like logic of converting the data that is already stored on your Hive clusters, right? So you can actually take in these custom MapReduce jobs, submit these jobs using our meta layer to the Hive clusters, which will process that data. Then Hive will actually come into picture and bring out that output that is already prepared out of that conversion. It will provide that data back to our meta layer, which will actually create a virtual data layer over that data, and you can actually create reports and dashboards over that data, processed data, which is being processed by your custom MapReduce job. Okay, so that is the idea that where we are trying to go. Next is like we have our own transformations. Like I talked about the filtering transformation and all those transformations. The other transformations we are trying and bringing a library of transformations for our meta layer. So all those transformations, we would like to provide some kind of MapReduce implementations for those transformations, which then can be submitted to a Hadoop cluster for execution, and data being processed by Intellicus MapReduce transformations over Hadoop clusters and provide you reporting over that data. It can actually be a series of mapper and reducer implementations. You can actually chain multiple implementations of MapReduce and achieve a transformation over the data that is actually stored on the Hadoop file system. So the idea here is all the processing is being done at the Hadoop cluster, right? Nothing is being brought for processing or reporting into the individual like systems, which can be a normal commodity hardware, right? So we are trying to use the Hadoop capabilities for processing, doing all the processing, so to reduce the data redundancy, time, maintainability problems, of trying to address all those things by using the capability power of Hadoop and Hive, right? So we would like to have a predefined library of MapReduce jobs wherein you can actually use these libraries for doing those transformations. Maybe if it turns out to be an open source, then everyone can come in and contribute to it, add value to it. These kind of libraries, use these libraries in their own transformations that they require. And then we would like to have a mechanism of providing an monitoring option over the processes that are being executed as MapReduce jobs, right? So it has to be like an asynchronous combination of asynchronous execution of job that you have already submitted, right? And then viewing that or monitoring that job using Intellicus, like what progress it has already made, right? Because running a MapReduce job can actually run into days, right? It's not always possible to get results in minutes, right? So there should be a mechanism wherein you can actually submit those jobs asynchronously and expect results coming out of like in weeks, right? So it has to be an asynchronous mode of execution, and a monitoring system should be there to identify that the jobs are still running, right? It should not be the case like you don't even get to know what you have actually submitted, what's the progress of that. So to overcome that kind of problem, we are trying to bring in these kind of capabilities. Now, the next thing that we are looking forward to do using this complete solution is providing a mechanism of manipulating and integrating and joining structured as well as unstructured data, wherein you have a scenario wherein some of the data is actually present in your RDBMS systems, right? And some of the data is actually present in unstructured form over a Hadoop file system, right? So what we are trying to bring in here is you can pull out data from the Hadoop file system, you can pull out data from the RDBMS data source. You do not need to move that data anywhere for doing operations on that data. So once you have that data, now you apply MapReduce jobs over that data or transformation capabilities provided by Intellicus over that data, and combine that data and then provide reporting or dashboards over that data. So that is what we are trying to do here, right? So I guess we have some time, right, for the presentation. So I'll do a quick demo of what we currently have done with the. So this is basically our application, wherein I'll try to show you how we are actually pulling out data from Hadoop cluster and creating dashboards and reports over it. Okay, so once I log in into the system, so we have created certain dashboards over this data that is actually this kind of dummy data, because you cannot expect it to be a very fast system when it is coming out from Hadoop. So we are actually dealing with some dummy data at this point of time. So this data is actually coming out from a Hadoop system. Okay. Yes, there is some problem with your solution. So these are the dashboards that we have created out of the data that is basically this is some transactional logs that are actually present on a Hadoop cluster. So now what we are doing is using Hive, we are bringing in that data by writing some SQLs and creating charts over that data. So therein where we say that we are actually creating a visual representation of that data that is actually present on a Hadoop file system. We are not caching this data anywhere in our system. It's directly coming from Hadoop system, and we are just showing it up and in form of summarized charts information over the browser, right? So it is not being cached at any level in terms of like, but you can certainly do that caching. The options are there. You can actually do it at the server level to reduce the trips to the Hadoop clusters, right? So options are there, but it's all real-time data that is actually coming in. So I have certain dashboards that we have created over the RDBMS. So what I want to show here is like these these are certain dashboards that we have created over RDBMS kind of data, but there is no reason that this cannot actually be done over a Hadoop file system, right? You can actually create tabular reports or some representative reports in terms of charts over this kind of data using Hive and Intellicus, right? So now I'll quickly show you one report that I have created over the CDR kind of database called data recorder, wherein data is being churned out onto a Hadoop file system from a call recorder, like the calls being made from one phone to another phone. Okay, so the complete data is being churned out of a system onto a Hadoop file system, and we have created a report over that data, which is actually a plain CSV file. So you can actually see these are the numbers from where the calls were being made, right? And this is purely coming out of from a CSV file, right? And the data is not being brought in anywhere in between, like cached anywhere, and it's coming out from Hadoop files. So you can actually apply filters over that data. You want to do analysis over, okay, what calls are being made from which number, the relationships between those numbers. So these kind of capabilities, that is what we are trying to bring in on that kind of data that is actually present on a Hadoop file system. I'm sure not very many options are available at this point of time in the market which actually provides you with these kind of capabilities, right? So let me show you the state of that data. So we have this is the data that I was talking about. So this is a plain CSV file that is actually storing that data. Merely got 10,000 records at this point of time, but certainly it is doable for any number of records depending on the number of machines you actually put in for your cluster nodes, right? So these are the tables that we have in our Hadoop Hive server that we have created, right? A small number of tables at this point of time, but certainly these tables can actually be provided on the designer of Intellicus, where you can just drag and drop things and create virtual data layer over these objects, wherein the data will finally be fetched from the Hadoop cluster at the time of running these reports or dashboards or charts, right? So the idea here is to reduce those bottlenecks that are there in between, like to bring in data into a data warehouse and then bring in reporting over it. Can we do direct reporting over the data that is actually stored, which already has those capabilities in terms of scalability, efficiency, or rather scalability and failover kind of mechanism. So any questions regarding
design view of that report?
The design for that report? This is basically that report that we have designed. Apologies for this resolution, but I think the incompatibility of the projector and the resolution of the laptop is causing this. So we have this table representation, like the virtual data representation of the table that is there on Hive server, which is basically a CSV file. Okay, and we have actually created a linkage between the calling number and the dial number, right? And that is what is being showed in form of a network chart over that. So you can specify certain criteria, like it provides you with an option of like what criteria on which you want to filter out the data. So all these options are actually available on the browser itself. You can just do right click and change the criteria from there. So this is what we call as ad hoc querying of data, ad hoc transformations being applied on that data. So these transformations are being converted into form of Hive where clauses, which in turn gets converted into a MapReduce job at Hadoop. So that is the complete idea of bringing in data out of the system and presenting it in a very flashy form to the end user, so that he can actually say that, okay, I am dealing with information rather than data. Okay.
So, I mean, whatever interface you design, is it generic or depends on the case scenario? I mean, suppose in the case of CDRs, you generate that graph, right?
Right.
But instead of CDRs, if the scenario is something else.
As in?
So maybe the data may be, let's say, chemical structure of chemical compounds, right? Something like that.
Okay.
Maybe the graph may not be, I mean, making graph may not make sense, right?
Right.
So have you,
yes,
I think you have identified some common operations which are going to arrive in majority of the situations, and that's what you are going to represent, or?
It's basically the data virtual layer that you actually create. It provides you records and form that are actually coming from a database, right? Now, you can actually use those records for creating charts, doing comparisons using those charts, or you can convert those records in form of a matrix where you have x and y axis and doing some calculations of summaries on the cells, or you can actually bring that out in form of a tabular report where each record is represented in form of individual records, or you can do grouping over it. So it's basically generic use of that information in various forms. So that is what we are trying to do here. The idea here is that as long as we can use the capabilities of Hive, like the MapReduce jobs that are already provided by Hive, we'll use them to use the computational power of the system or the setup that we have, right? After that, we'll try to bring in our analysis expertise for analyzing that data. So
the graph, you should have a graph, right?
Yeah.
So who is completing that graph? Your Hive query, or?
It's Hive query is just bringing in data.
And then you make
that data,
graph maker algorithm, and then.
Yeah, we have our own implementation for converting that data into that form which that graph actually understands. Okay, so that implementation is there. We give these objects to our components, the converted objects, and they actually draw that graph. So the data is generally the same graph. You can actually see it from, like, if your data is on RDBMS, you can actually see that for RDBMS as well. Or say you have some data on Oracle and MS SQL, right? And you want to merge that data and create a graph out of that data. So you can actually do that. So it's not that the data has to come into a specific way to create these kind of graphs. No, it's not like that. The data can come in any form. We'll convert it as per our own requirement and show it. And all these things are being done in a parallel manner, so that you don't hit that kind of bottleneck wherein you have to wait for the whole complete data to be processed and then start working on all those things.
So like you have developed the sort of plugins for all the formats, like you told that data that is coming from the Hive, it was being displayed in the form of charts. So is it possible to put it to Excel files or PDFs?
Yeah, certainly. See, I'm not sure, like at this point of time I'll be able to show you converting this report into a chart or not, but certainly you can, what you can actually do is, the other dashboards that I showed you, you can actually generate PDF as well as Excel out of those reports. So this data is also coming from basically Hadoop cluster, and you can actually generate a PDF out of this, so that you can actually share it with others. So these are the delivery platforms that that also comes into picture. Like you have a system wherein you actually analyze the data, but how do you share that data with others? So we are trying to bring in a complete solution which provides you with this kind of framework where you actually analyze that data, discuss over that data, collaborate over that data, and share it with others as well. Right? So this is the PDF. It's almost like similar PDF that you actually saw for HTML. So we have options of converting this kind of information into Excel, as well as like PDF, PPT, doc, various formats that are available. You can actually email this report from the system itself. It will automatically go to anyone. You can actually do any kind of operations, delivery operations associated with it. Right. So this is a complete solution that we are talking about in terms of analyzing and distributing that information.
So we will not talk too much about Intellicus, some of this game plan. But Intellicus is something very similar to Crystal Reports or Jaspersoft or any other reporting tool that you might be aware of. And it has all the capabilities of what any big reporting tool can provide. So what Intellicus has done is provided an interface over Hive. So you can actually design any kind of report over Hive, over Hadoop file system, and leverage the power of Hadoop itself. So this is one way to bridge the gap between manual analytics on Hadoop and the rich UI interface that any reporting tool can provide. I think we should be taking more questions as part of the discussion panel now.
Thank you, Sanjay. Next, we will be having, as said by Sanjay, a panel discussion. But before that, I think that there should be a tea break, get charged up. So you all please have it, and it should be a quick break. So please be back in 10 minutes.